Hello students, in last lecture we have seen data types in C, operators and expressions, and from operators we have completed arithmetic and relational operators. Now we will start logical operators. Next operator is logical operators. Whenever we want to test more than one condition at a time and we want to take decision depending on that result, then we can use logical operators. So we can say that logical operators are used to combine two or more expressions. Here the whole expression is then called as logical expression and its result will be either true or false. There are three logical operators. That operators are given in the table. First operator is logical NOT. Then ampersand sign is used for logical and third one is a logical OR. Now in next table, truth table is also given for and OR operator, and this and OR operation is for two operands, operand 1 and operand 2. You can go through this table. Now we will see example of logical operators. First is marks greater than or equal to 60 and marks less than 70. If both of the expressions are resulting true, then only this total expression will result true. Otherwise, if any one of them is false, then it will result false. But in second example, OR operator is used. Age is greater or equal to 25 or salary greater than 10,000. As OR operator is used, any one of them is true, then the total expression will result true value or true answer. If both of the expressions are resulting false, then only OR operator will result false. So by using truth table, we can find out the result of these operations. In this table, precedence and associativity of logical operators is given. So the priority or precedence is divided into three steps. The NOT operator is having highest precedence. After that there is AND operator, and after that there is OR operator. For NOT operator, the associativity is right to left. For AND operator and for OR operator, the associativity is from left to right. Now, if in our expression there are many small expressions, then whenever we are having answer of left operand, means if we are knowing the result of logical operation of left operand, then we will not evaluate or execute the right operand. For example, see here, A is greater than B and A is 10 is less than 5. Now see the LHS expression, A is greater than B. Its result is false. Its result is false. Therefore, as AND operator is used, even if the right one is true, the overall result of the expression will be false. Therefore, the right operation will not be performed or it will not be evaluated. That is, 10 less than 5 will not be evaluated because AND operator is used here. and the LHS result is false. So of course overall result will be false in every case. Next type of operators are increment and decrement operators. Now from their name we can understand what can be the use of these operators. C is providing us these two useful unary operators which can perform an operation on a single operand. So increment operator plus plus is used to increment the value of operand or variable by 1, and decrement operator, that is minus minus, is used to decrement the value of the variable or operand by 1. Use of these two operators is given in the table. First column is showing an operator. Second, meaning of the operator is given, and in third column use of that operator is given. So consider plus plus. It is called as increment operator, and we can write it a plus plus or plus plus a, and meaning of it is we are incrementing the value of a by 1. Therefore a is equal to a plus 1. Then minus minus operator, its meaning is for decrement. We can write it as a minus minus or minus minus a, and its meaning is a is equal to a minus 1. Therefore value of variable a is decremented by 1. These increment and decrement operators are used in two ways in an expression. The first way is prefix. So when we say prefix, then the operator is written before the operand. Here the increment or decrement on that operand is done before the use of that operand in an expression. So before using that operand in an expression, it will be incremented or decremented. For example, plus plus n minus minus x. So it will be incremented or decremented first, and then it will be used in an expression. Second way of using it is postfix. Again, as its name suggests, post means the operator is written after the operand, and important thing is the increment or decrement on that operand is done after the value is used in an expression. So that value will be used first and then it will be incremented or decremented. For example, n plus plus or x minus minus. These prefix and postfix forms which we have discussed just now are not making any difference when they are used independently or separately. But whenever they are used in an expression, then we can say they are different behavior. For example, consider integer n is equal to 5. When we are writing n plus plus, then its meaning will be n is equal to n plus 1. And when we say plus plus n, then also it means that n is equal to n plus 1. But now consider the next example. If an expression is y is equal to plus plus n. So plus plus operator is before n, therefore it is prefix form, and in prefix its value will be incremented first and then it will be used. Therefore here n is equal to n plus 1, so increment will be first and then n will be assigned to y. Okay, and second, when we say y is equal to n plus plus, This is postfix form. In postfix, we have said that the value will be used first. Operand will be used first and then it will be incremented or decremented. Therefore, here value of n will be assigned to y first and then it will be incremented. Therefore, y is equal to n and then there will be n is equal to n plus 1. So this is how prefix and postfix will behave in an expression. The next type of operator is bitwise operators. Whenever we want to perform the operation on data at bit level, then we can use bitwise operators. And these operators are only applied to integral operands, that is character and integer. Why characters? Because you know that they are stored with their ASCII values. In this table, all bitwise operators and their description is given. So bitwise operators are bitwise AND, bitwise OR, then bitwise exclusive OR, shift left operator, shift right operator, and last one is ones complement. Now we will discuss one example for bitwise operators. Suppose we are having two integers a and b and their values are 13 and 7 respectively. If an integer occupies 2 bytes, then a and b are in binary form, which are shown in the table, and as it requires 2 bytes, therefore it is represented in terms of 16 bits. So in first row it is A and in second row it is B. So the operators and or are used here, A and B. Now from truth table you know that 1 and 1 gives us 1, then 0 1 0, 1 1 1, 1 0 0, and remaining all to the left side are zeros as it is. Then second operator used is OR. We know that if any one of the operand is having value 1, then it will result as 1. So when we say A or B, 1 1 it will give 1, 0 1 again it will give 1, 1 1 it will give 1, and 1 0 also gives 1, and all leftmost zeros will be as it is. So this is how we can use and OR operators. Now next will be exclusive OR. Here in exclusive OR, whenever both the bits are or both the digits are similar, then answer will be 0. Therefore 1 1 0, 0 1 1, next will be 1 1 0 and 1 0 1. This will be the answer, and again as usual remaining zeros will be as it is. And the last operator used is ones complement. You know ones complement, that is it will replace 0 by 1 and 1 by 0. So it is just toggling the digit. So we are here using ones complement of A. Therefore only consider the value of A, that is 1101, and ones complement of it is replace every 1 by 0 and 0 by 1. Therefore last 4 bits will be 0 0 1 0, and then all leftmost zeros will be converted or replaced by 1. So this is how we can use the operators. By using bitwise shift operators, we can shift the bit pattern to specific positions to the left or to the right by using the operators. Its syntax is, first we have to write operand 1, then particular shift operator, that is left shift or right shift, and then there will be operand 2. Whenever data is shifted to the left position, then the trailing or rightmost empty spaces will be filled by zeros. And opposite to that, whenever data is shifted towards right, then the leading or starting empty spaces will be filled by zeros. Now we will see example of left shift operator. Here one unsigned integer y is given, its bit pattern is given, and we want to shift the pattern one position to the left. So whenever the pattern is shifted one position to the left, then leftmost 0 will not be there in the pattern, so it will be get removed, and then the remaining pattern will be 1 1 0 0. Okay, 4 bits. After that 1 1 1 1, next 4 bits, then there will be 0 0 1 0, again next 4 bits, and remaining bits are 0 1 1. So there are only 3 bits and remaining bit will be filled by 0. So this will be the resultant bit pattern whenever it is shifted one position to the left. Now you can try the second example. We will see again one example of right shift operator. Here one integer x is given with its bit pattern, and we want to shift this pattern 3 positions towards right. So whenever 3 positions are shifted, then last 3 digits or bits 1 0 0 will not be there in the resultant pattern. So from right we are having only this 1. So this 1 1 0 1. Okay. So these are last 4 digits, then 0 0 0 1. After that again 0 0 0 1. This is third position, 4 bits. Now only 1 0 is remaining over there, so we will write that 0. Now 3 positions are vacant and that will be filled by 3 zeros. So this is how we can shift the pattern to the right position. Now you can try for second example. Now next operator is assignment operator. It is the simplest operator. Here assignment operator is nothing but assigning the value of an expression to a variable. So expression will be solved first and then its result will be assigned to the leftmost variable, and for that equal to sign is used. So equal to is nothing but assignment operator. Now see what is the syntax. Variable is equal to expression. For example, sum is equal to a plus 10. So a plus 10 will be evaluated first and then the result will be assigned to the variable sum. Assignment operators are having lowest priority and they are having associativity right to left. For example, here one expression is given, A is equal to B is equal to C. So two equal to operators are used here. Therefore, we have to go for their associativity. And just we have said that associativity is from right to left. Therefore, the rightmost assignment operator will be used first, and therefore value of C will be assigned to B first, and then value of B will be assigned to A. This is how we can use assignment operators. Next is shorthand assignment operators. In this, we are combining operator with the equal to operator. Okay, so certain operator will be combined with equal to operator, and then we form a shorthand assignment operator. Now in this table, assignment which is generally we are writing is given, its shorthand assignment is also given, and operator used for that is given, and its meaning is also given. So let us see one by one. First assignment is n is equal to n plus 1. This is how we can generally write some operand and operator combination. Now whenever we want to convert this into shorthand assignment, we have to combine this plus with equal to. So it will become n plus equal to 1. So meaning will be same, only we are using here shorthand assignment. So which operator is used here? Plus equal to, and its meaning is sum and assign. So first of all find out n plus 1, and then that value will be assigned to LHS n. Next is n is equal to n minus 50. This can be written as n minus equal to 50. Next is n is equal to n into 10. That can be written as n into equal to 10. N is equal to n divided by 6 or n slash 6. We can write this n slash equal to 6. N is equal to n mod 5. We can write this as n mod equal to 5. So first it will use the operator, and then value will be assigned to the leftmost n. This can be the explanation of shorthand assignment operators. Now next is conditional operator. This is the only one ternary operator in C. So conditional operator is the ternary operator in C language. Its syntax is expression 1 question mark, because that is some condition, expression 2 colon expression 3. Okay, so first of all this expression 1 will be evaluated or solved, and depending on its result or answer, the next actions will be taken. So expression 1 is evaluated first. Then if answer of expression 1 is true, okay, or non-zero, then expression 2 will be evaluated, and then it will be the answer of this conditional expression. But if answer of expression 1 is false, if answer of expression 1 is false or 0, then expression 3 will be get evaluated, and it will be the answer of conditional expression. Consider the example of ternary operator. Suppose two integers are given, a is equal to 10 and b is equal to 15, and one expression is given. Here LHS is max. So max is equal to a greater than b question mark a colon b. So a greater than b is expression 1. So we will evaluate that expression 1, and depending on result of that, the action will be taken. So here A is equal to 10 and B is equal to 15. So we will check whether 10 greater than 15. Answer is no. That is, answer is false. Answer is false. Therefore, expression 2 will not be evaluated. Expression 3 will be evaluated. That is, B will be evaluated, and here value of B is 15, and that will be the result of the total expression. So value of B, that is 15, will be assigned to the variable max. The priority of conditional operator is after the logical OR and before the assignment operator, and associativity of this operator, conditional operator, is left to right. So this is the example of conditional operator. This is all about today's lecture. Thank you so much.